So yeah, we're gonna get started now. I know some people might file in and stuff like that. For the record, if we'll just have this recording, I'll make sure to share it out with you guys, like I mentioned. Um, Forgive me if I get yawn a few times. My twins just had their like 4-month shots yesterday, and they've been fussy like all night into like the today. So kind of been kind of crazy, but life goes on. And they're doing well. They're just got a little fussy because no one likes shots. All right. So the main purpose of today is going to be talking about like Git and like GitHub, and I'm trying to focus it more in the sense of like what we do for data science. I'm not going to talk about everything on GitHub or Git and stuff like that. I am not a master in Git. There's so many things that I learn every single time. I'm like, oh, I didn't know that was possible. There's also more and more evolving techniques that people are using in data science and machine learning that I'm just not going to go into. But I think this is a good first start and to see kind of like what kind of power you have with Git, and then also making it a little more usable for you. So that's kind of the idea of today. But as I kind of have a workflow and everything like that, I'm going to show you guys. If you guys have any questions at all, even if it's like kind of tangentially related, like feel free to interrupt me, or kind of if you send in the chat, I might miss it. So like feel free to like unmute and just say, oh, I had a question, or can you repeat that, or I had something about this thing. I'm pretty chill with that. I'll make mistakes and stuff like that. So I'll try my best not to like tell you something that's wrong to make sure you guys don't like do something that like will be drastic, whatever. But I'm human. All right, so let me go ahead and start sharing my screen, and we'll get started with what we have. So as I share my screen, like I mentioned earlier, I had a document for you guys. I'll move you guys over here so I can quickly look at you guys if you guys have any, you're too confused or anything. I had a document that we were going to use, if you had any questions. Doesn't look like anyone put any questions down. So either no one knew it existed or people don't have any questions. If you guys do have questions though, don't feel free to like interrupt me, like I said. Okay. All right. So like I shared with everyone on the Zoom chat already, we're going to mostly use this repo, and I try to kind of put everything together that I'm going to talk about in here. I might edit it later on, or like add a few things, or even like kind of reword some stuff. It's always a work in progress and stuff. So feel free to kind of like look at this. If you want to like, reference it or whatever, like you guys know how to kind of bookmark stuff. GitHub has stars and stuff like that. So maybe if you like doing that, if you want to make it your own, you can make it like a fork. If you see like an error in here, like feel free to like point that out too, right? Like on GitHub, and I'll be happy to include and fix that error. All right, so let's check out what this repo is. So I'm just going to look up this README right here. So I kind of broke into 3 major parts, and we'll kind of go order by order here. The first thing is basically like terminal tips, like things when we're using our terminal, like you guys know what I mean by terminal, right? Like your terminal emulator. If you have Windows, you might use Git Bash. If you have Mac, you have the terminal built in. I use something called iTerm. I don't know if anyone's familiar with that. It lets me do like cool kind of stuff, like things come in from the side over here, which makes it really nice and easy for me to like kind of put my terminal away, put it off to the side. So really convenient stuff. But we're going to talk about a little bit of like, what we can do with Git, because just a quick thumbs up, like, because I know some people use Git desktop. Who like consistently uses Git with the terminal? Just give me a quick thumbs up. All right, or hands, that's good. Okay, so that's good. I've already talked to my cohort about this before. I'm a little biased towards the terminal. I'm like, yes, like learn how to use it, because it's a good, consistent like place to be. If you use GitHub desktop or what other UI, tool, like awesome. But I do say is that it is nice to know how to use this kind of command line tool, because that means you can SSH, which means you can remote log into other computers and stuff like this, which a lot of times happens in data science, machine learning, because our computers are not powerful enough. Usually it's something on the cloud itself. And this way you can always be consistent on here, and you'll know how to make this work. It's a good thing to know. And then if you feel like it's like, oh, I just want a little like, user interface where I can like drag and drop stuff and things like that. I don't use GitHub desktop, so I don't actually know how it works. But if you use something like that, at least you can have a fallback where like if you don't have it available, for example, GitHub desktop is not available on Linux. It's only on Mac and Windows. So a lot of computers are on Linux. So it's kind of nice to be able to use this kind of interface. Okay. So we'll go over terminal tips, and then we'll kind of talk a little bit more about like Git beyond like what's in the curriculum. So beyond like the Git add, Git commit, Git push, Git pull and stuff like that. While I talk about like signing your commits, I'm not going to do like a full tutorial on every single part of this, but I want to show you guys what you can do and like how they're useful. So we'll talk about signing your commits, tags, which will relate to releases, and then different remotes. So if you have a different remote, you can actually send it not just to GitHub, but to other places on the cloud, right? And then branches and stuff, which I know is kind of mentioned, but it's kind of useful to talk about like why branches exist, because sometimes we'll do projects and you're just like, what's the point of me making a branch? And then the last part is going to be talk about folks about large files. And this is probably the most relevant to like data science in particular, because we deal with large data sets, right? And as you guys may or may not have already come across, just from experience, you try adding a data set and you try pushing it, and GitHub is like, whoa, no, I don't like that. And we'll kind of talk about, first of all, how do we do to avoid that completely? And then also, like, if we get into that kind of stuck place, like how can we get ourselves out of it? Actually, another instructor, Aaron Hoffman, wrote a great article talking about how to exactly do that. Like if you make it, like add your Git or your repo to your, or sorry, add your data to your repo, how to unfix yourself, or not unfix, fix yourself, right? To make sure that data is not in there anymore, and then continue on. But then we'll talk about a little bit of like a couple solutions. Git LFS, has anyone heard of Git LFS before? Some nods. Yeah, I'm not a huge fan of it for data science stuff. I'll kind of talk a little bit why. I see some head shakes and stuff. It's a little cumbersome. So it's a solution. GitHub releases is something I found relatively recently that I think works really well for small workflows. This is kind of like just showing you a little bit like what you can do with data science and like making models, working with data, like what kind of like flexibility you can have. And I'll be honest, it's like, this is probably not the best production wise. Like if you're in industry, like actually working with like other data scientists overall, there's a few reasons why, but it'll show you a little bit like what's possible. And it's not too much of a stretch to then look in something more automated, like AWS or Google Cloud Platform, where you're adding in basically your model artifacts and such and documenting those parts. So I think it's a kind of a good, like, if you could use like this, for example, for your current projects you guys are doing, I think that'd be a great start. Okay, cool. All right, so enough talking about what we're going to do. Let's actually do something. So let's see here. We're going to start with adjusting terminal for Git. So I'm just going to leave this terminal on the side here. Hopefully you guys can see it, all right? It's not too small, right? Pretty good. Okay, cool. So we'll kind of go through this part. So the first thing is kind of nice is that when you guys have used the Git on here, if you do like Git status and you do tab, like if you guys know this already on terminal, if you tab, it will try to fill in what your next command is. If you try this with Git, with like out of the box, it doesn't work because you have like Git status, right? Or, different commands and stuff like this. It'll just kind of like stick there and won't know what to do. So the nice thing we can actually do is actually make these like autocomplete going on here. And it's actually not too hard to do. So one thing is like, I talked about bash, ZSH, just know that if you're Mac now, Catalina uses ZSH as default, which is a little different from bash, which is what I'm actually using and what Git bash is using, but it's about the same. But what's cool about it is there's an actual script that you can just add into your profile, your configuration file, and this allows you basically to do autocomplete and do some really amazing stuff. What's nice too is like, well, what is this file from? This is actually from the official Git repository. So you can actually download and install Git directly from here. It's actually built into the completion. You can see here, contribution completion, and then Git completion here. In fact, there's a few ones. I have bash here, but you can also do CSH. If you do TCSH, if anyone knows what that is, you can do those kind of things in here, and there's profiles for it. I think ZSH and the bash one are relatively similar. I think the main thing is that there's a different like set of like setting parameters and stuff like this. I haven't used it, but I guess that's the one that you would use. So
I recently updated my computer, and so it has that now, and it just operates. It seems like everything's the same.
Yeah, ZSH is
at least for like what I do.
Yeah, it's a little more advanced. Like it can do it's meant more for interactive parts in the terminal, which bash is kind of like really old school, where it's like all you could do was type in commands and press enter, where now we can actually like use the keyboard select thing and stuff like that. ZSH really supports that. But it's mostly the same. That's kind of my understanding from it. I've been a bash person for my whole time. My younger brother, who's a software developer, he has gone on the ZSH train a couple years ago, and he like loves it. So just kind of know like you'll probably see more and more people use this, just because it's just the default on Mac. So, but you'll see a lot of things on bash too. Cool. All right. So let's see how we can actually add this then. I talked about this configuration file. So has anyone ever seen like .bash profile? Give a thumbs up if you've kind of seen that. Like maybe not understand what it is, but like you've seen it somewhere, like maybe in the tutorial or something like that. Okay, see some blank look, that's okay. So this .bash profile basically is loaded every time, in this case, my bash shell which this is right here, every time this gets loaded in there, it'll actually load that into there, load like this configuration and let me do all these really cool things. So it's kind of useful to see like what is inside this file. So don't get too scared first, right? Because it's going to be like a lot of like weird looking like settings and stuff like this. But basically what this does allows me to like configure like how I want to interact with my shell itself. So you'll actually notice this part right here. You probably already have this in your .bash profile and not even realize it, because Conda actually automatically installs this on here and basically allows you to do like looking at like what Conda environment you're in and stuff like this. But you can see some extra stuff here. Like this is just more for me to just kind of like customize the way it looks and stuff like that. It makes it easier. I can also use certain what's it called? Different programming languages, like where those lives, like Spark, Java, Scala, stuff like that. This right here is actually, I don't know if you guys have heard of the fuck. Like this is a repo. Okay, this is a nice little thing because it allows you to correct if you accidentally type the wrong thing. You can just say, why put an alias that's oops, because I think it's fun. I just put oops, and then it'll say, oh, did you mean this? And then it'll correct it automatically. So it's really useful. Yeah, if you guys know, see if I can find this on GitHub. Yeah, there we go. It's a little tangent, but like I think it's really useful. So the idea there is you type something slightly wrong, it'll try to correct and say, oh, you didn't quite mean that. And you can say, in this case, they use the F word, right? But like you can put whatever, you can alias it to whatever you want, and then it corrects it for you. So anyway, that's what's going on here. But what we want is we want to just autocorrect. Like that's simply what we want to do. So a simple command we can just simply like do is literally run echo source, and this is the tilde, right? Back or / get completion.bash, assuming that this get completion.bash is actually exists there. So if you look at my guy, if I go ls -la of .get, oops, it's got to get config. I actually keep it in, where do I keep it? I should probably pay attention to what I'm typing first. So you can put it wherever you want, as wherever you put it in this case, where did I put it? There it is. I put in my .bash configuration file. So I like to put like a little dot to keep it hidden. That way it's not like clouding up like my whole like the home directory. But you save this file, right? And then you can say, okay, take this guy right here. And this is basically getting added onto your bash profile. That's what this double arrows mean. Just saying, oh, add it to the end of your bash profile. So I'll just show you what this looks like. So if you can see right here, like this is my whole system, and you can see this actually my being able to enable tab completion for GitHub or for Git. If you look, this is the very last line, 48, which is right here. If I run this command now, oops, not that command. I'll just type it in directly. So echo and then source. Well, this, in my case, is going to be in the .bash config, right? I'm trying to remember where it was. It was in the ., right? Who was paying attention? I think it was bash config, right? There it is. Okay. I just had to make sure I was actually going to do something. So I go echo, and then it's just say, okay, just repeat this directly into there. And it's going to do the bash config. And then it's going to be get completion. I think I kept it the same name. Get completion. I have to like read my own right. I'm bad at spelling. Bash profile. And then it's going to, whatever, it's going to echo this. So if I just run this guy by itself, it just repeats that, nothing special. So I'm just saying, okay, go ahead, and we call this like piping it in. Like we're sending this output into the file that is my .bash profile. Okay, and then if I do go ahead and actually edit this guy, you can see, hey, there it is, at the very bottom here. So it's actually adding this in there. So that's the quick way you can like go ahead and like put this in here. Okay, once you have that in there, it can autocomplete. So I can do like get status. Oh, well, stash is, there's two different ones. If I do this, is stash, status, and stage. So I can do like status and it'll autocomplete there. It'll also do this, like, for example, I have different branches. So I can actually do like git checkout, and then I can do main, and it actually fills in those different branches and stuff like that, which is, again, super convenient because then I don't have to remember all these like super long names all the time. So this is really nice. And it's a super long, like you saw how big this like file is. Like this would be a pain to like actually try to like do yourself. Like it's much easier just to use it. And what's nice is that it's actually built in, but you can just download it, and I just save it into like a .dot file. Okay, cool. So this is tip number 1 for you guys. If you don't do anything else, I would probably do this because it makes life so much easier. Okay. Any questions on that? All right, I swear it's going to go a little bit faster now. Now that I kind of showed you a little bit like what's going on. All right, so kind of similar is this prompt right here, which if you notice right here, you guys probably don't see this when you guys are doing, you know, like you're using your normal bash and stuff like this. Usually yours would look something like, you know, like whatever, you know, maybe it's like your username or the directory. But this right here is super useful because what this is saying, for example, let's see git status. Let's do git add. Images. And you can see here, this will change actually depending on like, you know, what your staging area looks like and what's going on. So it's a really quick like thing. This actually represents what branch I'm on right now. We'll talk about branches in a bit. And you can see like, okay, I have stuff that's unstaged. I have stuff that's staged right now. And then when I commit it, this plus will go away. So it's a really convenient way to kind of quickly check this out. You can actually do a whole bunch of really crazy stuff, but that's the main thing I do. You can actually just go ahead and check out, again, a script, and it's the same repo. And it adds this whole bunch of stuff in here. And what I can do is I can go ahead, let's go ahead and add this into our source file, just like before, and I'll add into my bash profile, which allows me to use, you know, this extra prompt information. So what this looks like would be something like this. So I just wrote like a different one because I have my own separate like bash profile and I don't want to mess it up, right? But this was what you would put in here and be like, okay, let's do source, the prompt itself, which is this guy. This is just, remember, like if you save this somewhere else, it just means you have to put it somewhere else. I usually put these in like little folders that are hidden. That way I don't have to like mess around with it. And then this export git ps1 show dirty state equals 1. This just allows me to be able to use this guy right here. So I can actually say, okay, what is the current state of the my repo? So that's what this guy is doing right here. But then once I have this export ps1, this ps1 basically is my prompt. So this is exactly what you see to the right or to the left over here. And so in this case, I'm just putting my working directory. That's that \w, right? It's just saying, oh, that's my working directory, my current working directory. And then I have, in this case, saying, okay, there's a variable. That's what this $sign means. It's like, okay, whatever is git __ git ps1, which is just going to be like, oh, what's the current state that's going on here? And then I just add a little little $sign at the end just to make it easier to read. And what this looks like then is when I have different changes in here, I have my current working directory, and you can see how I make these changes, and that's what's in the parentheses right there. So it's a really nice, quick, and easy way to look at stuff. You can add these extra colors and stuff like that. So just to kind of show you guys a little bit what my profile looks like you can see there's different colors. You can look this stuff up. If you just look up bash profile customization, you can probably figure out a bunch of different stuff. And it's kind of fun to play around, customizing their stuff. But you can see here at the end of the day, this is really what I'm doing right here, which is this one. Well, I guess it's technically this one because I overwrote it. So this guy right here is basically saying, okay, like this case, I'm just saying, oh, it's green, which is the time. And then, I'm sorry, this is the time. And then this green right here is just saying, okay, that's going to be my changes in my Git staging, stuff like this. Again, a really convenient way to just quickly look at stuff on the terminal. Because if you're doing all your stuff on your terminal, then you can quickly see everything that's going on. Cool. All right. Any questions? Sound pretty good? Awesome. All right.
It looks like there's a question in the chat.
Oh, yeah. I don't think I see that. It doesn't pop up for me. Let me pull it up.
Okay.
I don't think you guys can see me click on this chat, right?
Yeah.
Okay. So most of my questions about Git come from mirroring at this point in time and attaching heads and reattaching them. Ooh, yeah, that's a fun one. So we'll kind of talk a little bit maybe that'll make more sense when we talk about branches and stuff. So Elizabeth, if you want to like bring that up again, like when you talk about branches, we can talk about Git checkout and like what that means. Let's hear. And then someone else asked, I think they just sent it to me personally, was asked about multiple repos in the same folder. Yeah, that's a tough one. If you can have multiple repos in one folder, but if you have a repo, like a Git repo, and then a Git repo within there, you can get in some crazy trouble sometimes, because if you add one, it adds it as a submodule, which GitHub is doing a little bit better in trying to make that easier to find. My suggestion is, unless you know what you're doing with that, probably try not to put repos within repos, just because then it makes it a little confusing of trying to manage that. The main thing you have to know about it is that when you make a repo within a repo, you guys know when I say repo and repo, can you guys visualize what that means, right? Okay, I see head nods. Okay, so when you have a repo within a repo, you basically have its own history of like the stuff in this directory, but then there's also like the history of this whole directory, which is going to include this thing. But Git's smart enough that when it sees that this is also a Git repo, it's like, oh, that's a Git repo. I'm not going to use that as like a normal, set of folders and files. I'm going to treat that as a history, and it creates a submodule. And basically what you see in this submodule is like when you do a Git push and you accidentally add, let's say you accidentally added this repo, you don't get all the files in here. You also get like a little like folder with a little arrow on it. It's like a different folder that you can't click. And it's basically saying, hey, this is like a different Git repo that's being referenced in here. So the idea there is that, like, let's say, for example, I use some software that's on like GitHub and I use that in my project, is that way people know it's like, oh, this part here is actually managed by a different team and they can get that specific, changes and stuff. So they get the more recent results or whatnot. And that's why it treats it that way. But for us, for the most of the time, data science, we don't really want that to happen. And usually people do this when they're trying to be like super organized and they actually add like a git add dot, right? And they add everything in the directory. So if that happens, there's a few things you can do. I'm going to just throw out the word rebase, and I'll tell you like that is a lot of work and stuff like this. And this is where people joke, like, I don't know if you guys have seen the XKCD comic of Git.
Actually, I did that by mistake, but I don't know how to fix it. I looked up online, so they asked me to access my hidden file .git and delete it, but I couldn't do that. And I figured that out when I tried to get add and get commit. This is when I figured out that I did multiple repo inside each other.
That's right. And so when you have that repo within itself, it's like it's this weird part. So I'll just kind of show you guys what that looks like. Is .git, which Huda, I don't know if I'm saying that right, but
Right.
okay, good. All right. Was saying is that you have this .git folder, which is hidden. Remember, dot folders are generally hidden in Unix systems. This .git basically tells the Git command line tool, it's like, hey, this is a special kind of folder, like this overall folder, and that's where your history is. So the thing is that if I make like a new directory, like let's say just new, yeah, I'm not super creative, everyone. All right, if I now make, you can see like this edits right here, but I can actually initialize once I'm inside this, I can do git init, right? You guys already know this. And then you can see here, it's like, hey, it changed, right? And that's because I'm now in a new Git history. I'm like within this little tiny history. So if I do get git log, for example, you can see there's nothing in here, right? But if I pop back out, right, you can see if I do git status, you'll see like, hey, there's this new directory in here. Like you can add that in there. That's pretty cool. If I did add this in here, that's when I get like this .git folder, and it basically says, oh, that's a submodule. And honestly, it's all kinds of mess. And that's where like people kind of joke is that like it's easier to sometimes just delete everything and to start over. That's kind of like the typical reaction when you get yourself into a mess. You can dig yourself out, but it does take a lot of work. So that's where again we'll say rebase, which is really just saying a lot of work. But maybe we'll go over a little bit of that too, about like not that specifically, but rebasing. Unless you guys would like me to kind of like try to show you guys what that scenario looks like. Okay. Let's see if we can get through, since we have, this is why I gave it an hour and a half versus an hour, because I knew it was going to be some extra questions and stuff. But
hey,
so,
Victor, one quick question.
Yeah.
How can we update only part of the, so when we do the Git status and then there are like say multiple updates that come in, and I just want to do part of it. So now like you had the new directory and the other one which updated, but then I just want to update one of them, not both the thing. When I commit or when I just change to, so can I select specific ones to be updated?
Yeah, so we have like this, your working space and then your staging area, and that's what this is right here, right? Is that this is your staged area. It's like, oh, these things are ready to be committed. So if I committed right now, I did git commit, it would only commit these files. Is that what you're asking? Like, so that way these things aren't committed onto, is that right?
So I wanted to know, like, let's say there are this like a new directory which needs to be committed, and there is this git attributes which needs to be committed. So instead of that, I just want to commit for only one of them instead of both the files.
So just this one folder right here.
Will that
right?
be possible?
Yeah, you can just simply, I don't know if you guys know this. So typically if you do like git add dot, that'll add everything, which is not what we want. If you want to add just that new directory to our commit, we can do git add new directory. And then if you do git status now, oops. Oh wait, I'm sorry. That might not be the best example because I have a history in there, but let's see. So let's do, let's just add just this images, this specific file, or does that make sense? Like I can do git add and then just that file. And then if I do git status, now you'll see only this file will be ready to be committed. So if I do git commit, only that file or that folder will be committed.
Perfect. Thanks. That's clear.
No problem.
Thank you.
Yeah, hopefully that's good for you guys. I know everyone does like git add dot. I never do that. I hate doing that because I always add the wrong thing in there. So anyway, that's my personal preference and stuff like that. Cool. All right, I'm gonna keep moving along and stuff like these are all really great questions. If you guys want to add them into that Google Doc, you guys know what Google Doc I'm talking about. If someone wants to share that and link in the chat, and that way, if we have extra time, we'll try to go over through a bunch of questions. Since I see there's a bunch of people who love all these different questions. Feel free to interrupt still, but I might just say, oh, we'll save that to the end. Okay, cool. All right, just moving right along then. Aliasing commands for Git. So this is really useful. Like for example, like if you guys do like git log, like this is nice. Like you can see all your different commits in your history, but it's like super long and like, I don't know, it's kind of cumbersome. And I don't get to really see how things have changed. So we actually use something called aliasing. I don't know if anyone's heard this term before, but basically it allows us to say, hey, do a different command for this kind of like set of commands or this one command. So one example that I always do is I literally put this as a gist on GitHub, is that I go ahead and just take this guy right here. You can say git configure global, which means it will change your whole system, whatever is going on. You could do this per repo, but I like to do it like overall because I know it works everywhere. And then I'm saying alias dot, and then whatever you want to use as the command for your alias. So for example, if I wanted to do, normally, if I did this guy right here, let's see, I'll show you guys. If I do git, oops, this thing, it makes this really pretty graph, which makes it easier for me to read and everything like that. Everything's concise. I can look at the commits, really nice and easy. This is a pain to type out every single time, even with tab completion, right? So what I want to do is like, well, I want to make something really short. In this case, I just say, all right, alias.lg, that's saying, okay, make the git lg, whatever that is, make this into this long this long command, do the same exact thing. And it makes my life a little bit easier because then I don't have to remember this long thing. I just remember this git lg. So just kind of show you guys a little bit what that would look like. If I do global, I'll just do global. That's fine. I can always delete it later. I'm gonna rename it something so I already have lg. Let's say just to do something different, right? log, right? So now if I do git log, it does the same exact command as if I did like that really long command, which again makes it super convenient. So people like to do things like, for example, like I don't really do this too much, but people do like git checkout and git branch and git, commit, they'll make aliases. I don't really like that because it makes me more confused. But like these ones that like, I'm like, I don't remember this super long command that I do every single time. I'll just make this as an alias. Okay. So a lot of fun you can have on here. Any questions on that? Cool. All right. All right, so this one's one of my favorite things that, especially for data science stuff, is that if you ever do anything, let's see here, I think I actually have this in here, but if you ever do any like git diffs, you guys know what git diff is, right? So it's just showing you like what the difference is between the last command and the previous command. Oh, I actually have it, too nice. But it basically says like what things have changed, which is really useful because then you can try to track down what's going on. You can also, if I do git lg, you can see, I can compare this commit with my current stuff. So I'm like, oh, git diff of this guy, and it'll tell me what were the differences between my current state and my previous state before. This is actually what I'm going to show you guys is using nbdiff. But you get all like typically if you try to doing like your Jupyter notebooks, they look like this. They're like, oh my gosh, it's actually nicer than before. So like you can be like in a lot of trouble, like not trouble, just trying to figure out like what's changing. nbdime is this extra tool, which is super useful. It stands for like notebook. I don't know what the dime actually stands for. It's probably difference. Oh, differencing and merging. I learned something new. Okay, differencing and merging. And what's nice about this, you can actually put this as an extension in Jupyter Notebook, but for Git, it's like, well, sometimes you just want to work with Git on here. You can actually configure this. So instead of having like, if you ever seen like this long thing right here, which is like this image and it's got this super long like nonsense in there, and all you want to know is just the image changed. It changes that into something like really readable. So it changes to something like this, like, oh, here's a new figure. It's changed to this figure. And like, that's all I wanted to know versus like the whole like long thing. You can actually enable this. So it's really easy to enable it. Well, I should say like the first thing you can do is actually use just do nbdiff and then notebook A, notebook B, and you can compare those two notebooks, which is like one version, but we're talking about Git here, right? So if we want it for Git, we actually enable it for, what's it called? Git in general. We can actually enable and disable it for like Git itself. So like I showed here, let's see, I think I have it in here. Here we go. I think this is, okay, cool. So this is a different file right here, or repo. And I have this plot. So I have actually, and let's see, test notebook, IPNB, and that's the one I've actually changed. If I did, I want to, let's see here. I'm going to disable it first. Oops. What are you doing? And be done. Config -git disable. Okay, I just want to make sure I disable it first. You wouldn't normally do this because that's what you'd want, right? So I want to compare this plot and this plot together. So because I changed the plots over, so I'm going to do a git diff between this guy and this guy, and we're going to see some funkiness. So like, okay, you guys have probably seen something like this when you do like a different thing, but look at this long thing. This is basically saying the image has changed. And this means like nothing other than the fact that it's like, oh, the image has changed. That's all that's changed. And you can see how annoying that is to actually read. Now, if I actually have this enabled now, it'll instead use the nbdime tool for differencing. And now if I actually do this right here, you can see it still shows me the changes, but it shows me like, for example, the output, oh, the image changed. That's all that you really need to know. And it makes it nice and clean, a lot easier to read through here. So this is a really useful tool, nbdime. And then for Git in particular, I would like just run this guy and just like never remember it ever again, other than like when you install nbdime again. But yeah, it makes life a little bit easier than having this long list of like differences and stuff, because trust me, like that happens all the time when you're working with other people. Someone's changed something, you're trying to figure out what's changed, and you have to figure out in the notebook, and it's a lot of work. Yeah, any questions on that? No, sound pretty good? All right, cool. Look at that, and we only went through 3 minutes. Oh, and I see more chats. All right, yeah, let me know, guys, if you guys send me a chat or something, or and I don't see it. Oh, good, thank you for sharing out the Google Doc. Yeah, as you guys have questions and stuff like that, feel free to add this in, and we'll try to get to it definitely when we have it at the end. Okay. All right, so this is our different adjusting terminal stuff. So it makes our terminal nice and neat and kind of fun to play with. Always really great things. So let me go ahead and go to the next notebook. So this is where we're going to start talking about more about that Git stuff. Is like, what else can we do? So this is where I'm going to talk a little bit about, you guys may or may not have noticed all this stuff. And then I'm going to talk a little bit about like, after we finish this stuff, is to talk about like what this means for releases. So some basics, right? You guys already know this. You get out a file name. We just showed that little example of that. So we can add everything. We can add specific files. We do our git commit, right? You can do a git commit -m to make a message, or you can just have it pop up, do your git push, and then you're done, right? Easy stuff. And basically, it's pretty much what XKCD says. Like, yeah, you just kind of do these certain commands over and over again and just kind of like work with that. So we can, once you get used to this, it's a little bit nicer to kind of figure out like, how are we doing things and what we can improve on it. So one thing we can do is really organize our commits, right? So one way we can organize this is something called branching. So kind of quick thumbs up, who's heard of branching or has done branching before? All right, so most people have at least heard of it, or maybe you tried it out yourself. So it's kind of useful to know is that branching allows us to basically make, some people compare it to like a parallel universe, which I think is like the best example of this, because Git is really like about your history. So if you look, when I do like git lg, you can see like this part right here, and I actually branched off into like a parallel universe essentially. So I can actually work in parallel on these two different parts, which sounds like for most one-term projects, most people aren't like, oh, I don't understand why I'd break off into different branching. I do think it's actually useful for a single person, but especially if you're working with a team, it makes it a lot easier where like we have this main branch that everyone can go to as the source of truth. And I branch off to my, Victor's branch. I can branch off to like Mike's branch. I can branch off to Jessica's branch or whatever it is, right? And then what we can do a different work, and then we can merge our work into this main branch over here. So that's what makes it like really useful. I always joke is that when I do my work, I try to pretend I'm working on a team, even though I'm a team of one. And so sometimes it's useful, like when, for example, I get like, oh, this is a great idea, but I don't want to like completely undo what I've already done and like delete stuff. And I just want to make some change. I'll actually make a branch, make changes on that branch, see if it works out. It's like, oh, that worked out really well, and merge it over. Sometimes if I've worked on, like, for example, I've done contract positions where I'll like work on something. It's like, oh, I think this isn't what the client asked for, but I think this might be relevant later on. I'll branch off to it and make that change and then continue working on like my main master branch. This has happened to me a few times where literally someone like working a contract position, they say, oh, hey, like we have to have you change this one thing. And I'm like, oh, I knew you change this. Like I just had a feeling this would be a change that they'd want. I said, oh, we have to have this change. Like, do you think you can do this? We'll pay you even more for it. I'm like, yeah, I can do that. And then I already had the branch over and I could just merge it directly over, and it just made life really easy. So instead of having to be like, oh shoot, like I know I could have made that change at this point. I have to like go back in the history and undo everything, get that point. I made some extra money because I was smart at the beginning. So that's kind of like what's nice about doing branches. And of course, it doesn't necessarily have to rely on money, but it's about your time too. So it's really useful to kind of make these different branches. Okay. So one thing I want to note is there's something called, all that from a branching. So we'll talk about how to branch in a second. So one thing I did want to mention is that there is a little bit of a change in syntax right now. So you'll see people talk about master, and you'll see people start talking about main and stuff like this. Note that the industry in general, like, is moving away from master, mostly from connotations of like what master means and stuff like this, which I think is honestly, personally, I think it's a good thing. But it just means that some places are trying to figure out how to change. It's going to take a while. But I think most people are converging onto main. Some are converging over to default and stuff like that, but main seems to be like the thing that people are using as like the master branch, which I think main makes more sense with what we're doing. So just know that we'll have this main, is the main branch right here. Sometimes it's called the master, and that we can branch off of it. And then you can see these different branches. For example, in this case, is a hotfix branch, develop branch. And this is going to be much more centered towards software development. But you can probably think of ways how data science is very similar to this. Like if we're making a new model, or we want to adjust this thing and we're like, we don't want to ruin the stuff that we already had, you can create a simple branch and add that in later on. Okay. But anyway, I just wanted to point out that master and main, just know that means the same thing. And that master is kind of being phased out more. Git still by default will do master, but you can edit this. I'm not going to go into the details exactly how to do this. You can look it up, like make Git, make main, your main, your default branching in Git. There's a whole bunch of documentation that people can look up and how to do this. It's actually not that hard. And then just know that GitHub, for example, has already, when you make a new repo, it'll make a main branch by default. So you can already see that change happening already. Okay. Also, nice thing about GitHub too is that I think other places are doing this like Bitbucket and GitLab, but if someone had master, right, but now they changed it to main and there's no more master branch, master will still work. It'll just go to the main branch. So they're trying to make it easy as possible, but no, there is that little bit of change. Okay, so let's talk about actually how to like make a branch, right? So we can actually do like someone mentions like, oh, can we do branching from branching? Yeah, you can. Basically, there's nothing special about the main branch. It's just branching from a specific direction, right? So I'm actually going to go to this guy right here. So this is my little example. I'm going to do git LG. And you can see here's my little commit history. I made it just because, just really quickly, you can see I'm really not exciting about my different commit name messages and stuff. But I can simply make a branch. So I do git branch. And what should we call this new branch? Any suggestions?
New branch.
New branch, I love it. All right, new branch. Okay, so then we can do git LG, and you can see here, hey, there's a new branch. And what that does right now, it just creates a new branch. And basically it's a way to point, if someone mentioned about head before, it's basically like another pointer saying, hey, this commit, that's where my branch is at. right? And that's all essentially what branches are doing. They're just tracking where this branch exists and pointing it across. So this doesn't really do anything
I have a
special.
question.
Yeah, go ahead.
Okay, so I've seen branches on GitHub before, and then I've seen the options when I'm using terminal, but what does it look like in a Jupyter notebook to have different branches? Or does it like, yeah, how does that
When you
work?
say what does it look like, you mean like when you're in the Jupyter notebook, like
Mhm.
what does that look like? Yeah, so when you're on a different branch, it's like you're in a different parallel universe. And this is where I'm gonna go very sci-fi, right? Is that when you're in a parallel universe, you kind of don't know what the other universe is like. You just know what your own universe is. So all your files are gonna be however your branch was formed and like is in its current state. It's just gonna know like, oh, this is the reality of like my Jupyter notebook. What that means basically is that your Jupyter notebook's not gonna look any different unless you have any special.
It'll just match the current branch, basically.
Exactly. Yeah.
Okay, cool.
Yeah. The biggest difference might happen is if you have a Jupyter notebook open, which you'll notice like, it's open and running, and you do on the terminal, you switch branches, which is called git checkout. If we go check out a new branch, you now are in a new parallel universe, but you have something running at the same time. Technically, the file is on the branch that you switched over to, but sometimes there's some weird conflict where like it's still running and it thinks it's open, and you might get a little pop-up that says, oh, reload or overwrite or something like that. The simplest way to do that, like it's just kind of like check yourself like, okay, can I undo all of this stuff, or is this important things? Now, the good thing is if you've been doing frequent git commits, even if you overwrite it and you're like, oh shoot, that was like all my work that I had on the main branch, you'll be fine because you can get reset it. But just that's a little quirk that you might find every once in a while. But other than that, it's like, yeah, it's like a new reality that like exists.
Cool, thank you.
No problem. Good question. All right. So like I mentioned, we can make a new branch called my new branch, right? But you'll notice that I'm not actually on new branch. I'm on main, right? So one thing I'll typically do, you can also create it calling git checkout, and then -b just means like, oh, I'm going to create a new branch. And give me a new name for this new branch. We're going to make a new one.
Live demo?
Live demo. See, we're getting creative now. All right, live demo. All right, so now if you can see this, my branch actually switched over, and you can see now, git lg, we got new branch, live demo, and main. So these are all in the same spot. So right now, parallel universes are perfectly fine, right? But if I were to make a new file, for example, I'm just gonna make a new one called touch. Like, you guys know what touch does, like in terminal? It just like literally just makes the file and doesn't put anything in it. So I'm gonna say touch new, I'll call branch file. Okay, and so you get status, git add new branch file, git commit -m, and commit. Okay, and now we can see here, say, hey, we now have a new commit that's on here that's ahead of everything else. And that makes sense because we're on the live demo branch and we're just kind of moving up on this. If I go ahead, if I want to switch back to, let's say, new branch again, I can do, does anyone got a guess of how I can switch back to this new branch part from where I am? I'll give you a hint, it starts with git.
Git branch, new branch.
You're close. It'll actually be git checkout. So branches create stuff. That's why I never use branch. I use just checkout. But you're close. You have git checkout, new branch, and now I'm on that new checkout. And if you look at my git lg, right, my log, you can see that my head basically is like where I am right now. It's pointing at new branch, this commit, and you can see my head. So now if I make a new commit, let's say I make a new file, touch other evil file. Okay, it's evil, so you can do that. And then commit this, sorry, evil commit. And if you get LG now, you'll see that they split up, and that's where that kind of picture going on. They branched off from each other. So they both share that same history until live demo had this lame commit message, right? And then new branch has this evil commit. So you can see a little bit like how you can do different parts, and this main can actually continue on and stuff like this. Cool, makes sense. And you can see I can just quickly, like, I can still do git checkout, main, git checkout, this other one, live demo, So I can just pop them over the place, right? I can even check out a different commit. So this right here, do you guys know what this is called right here? These like sets of numbers for get commits. So this is something called your hash. It's basically all your changes hashed together. And basically a hash, you can kind of summarize it as being like summarizing everything into a specific like naming system, but like you can kind of imagine like that's essentially what's going on. If you're familiar with cryptocurrencies, that's like all cryptocurrencies are basically just creating these hashes. But it's basically like my address in time on my Git commit. So think of like parallel universes. I'm like this little parallel universe like time machine thing that I can fly around wherever I want. This allows me to say, oh, fly to this point. So I can actually fly to this specific commit, or we call it checkout, you know, in Git. And I can see here, if I do a Git LG, you can see I'm actually right here. See, that's my head, right? And note that there's no branch associated with this. And that's why, for example, this is just like the commit name. I could actually, at this point, actually do git checkout, make a new branch, let's say old branch. And if I do git LG, now it's a little bit easier for me to like switch over to here. And I can actually change things on here, do different stuff like it normally would with any other branch. So this allows you to kind of quickly go back in time essentially. And note that if I, for example, git commit to, if I look at this, you'll see that I only have new 0, new 1, new 2, where before, if I do git checkout main, if I do ls, you can see I have all these other new files in here. So it's like literally going back in time. So kind of going back to Jessica's, like, what does that look like? It just it's like new, like it's as if like those files never existed. Okay, cool. All right, any questions? All right, awesome. So I already mentioned switching branches, so git checkout and then whatever branch you want, right? So you can also do that with commits. Later on, we'll talk about tags. You can actually do the same thing like git checkout in a specific tag, and it'll actually send you that specific tag. The last part is the merging branches. Now, merging is the one that's going to be like, I can talk all day about like merging and stuff like this. So we won't be able to do that because you can already see I've talked for about 15 minutes already, and we haven't only gone through half of the stuff. So I won't take forever to do this. But if you want, for example, let's do git LG, and I'm going to go back to, let's say I want to merge. I'm going to go back to, let's see here, I'm trying to think. Let's go to new branch. Okay. So let's check git LG. Let's say, for example, like, oh, cool, like I actually want to merge these two places together, right? They were working on separate stuff, and now I want to combine the changes together. So remember, evil commit had like some special evil file, and then late commit message had some other file that I made, right, really quickly. And I want to put those two together. So I actually have both of those files together. I actually can go ahead and merge these together. So what it is first, I have to say, okay, where am I going to be? So I do git checkout, and I can do git checkout main or wherever I want to be. In this case, I'm going to go to new branch, and then say, okay, git merge, and then it's going to merge wherever. In this case, I'm going to say a specific branch. And say whatever that branch is, it's going to merge onto wherever I'm sitting right now. So it's more like the way I picture merge is like you're kind of like taking a little lasso and throwing around your commit and bringing it to you versus like you merging it onto there. So that kind of helps a little bit, like when you do, like, how do you do a git merge? So now I'm going to take new branch, which I'm right here. And if I look at my like files, for example, you can see here, well, I don't have that committed. I don't have that committed. Oh, we'll just go for it. All right, so we'll do git merge live demo, right? So we'll do git merge live demo. And you can see here, it gives me a special commit. It's like, hey, you want to commit message now because we're making commit when we change this, right? And so I'm just going to leave this on here. That's the default. And now if I look at my git LG, you can see here, I had this original like live demo. I had my new branch, and now it's actually got a new commit message onto here, right? This new commit, and that should include everything from live demo and evil commit. So the way you can kind of read this, like this is my most recent part. I'm including the histories from this side and from this side and merging them together. Does that make sense to people? Cool. Any questions? Thumbs up if that made sense. Sides are like, I don't know what you're talking about. Okay, cool. Quick thumbs up, which is always a good sign. All right. Also note, I can also do, let's say, for example, let's say do git checkout main. And it's like, okay, like main's right here, but I want to get caught up to there. I can do git merge new branch. And you can see here, nothing happened. Why nothing happened? Oh, no, I'm sorry. I lied. I saw this part and I thought there was nothing happened. But you can see here I got zoomed up, right? Is that basically this is called a fast forward merge. And so you can fast forward. So basically it's just like, oh, we know where we're going at. We're just going to zoom up ahead. So this might happen a lot if you make changes and stuff, merge things together, and then fast forward your main branch. Okay, cool.
Victor, can I ask a quick question?
Yeah, go ahead.
What would happen if you merge and say, and granted this might not be the best way, but if two people were working on the same file name and you tried merging the two branches?
Like what would happen then?
Yeah.
Yeah, so this is a good point because one that kind of assumes a couple things, right? So one is that every time you do a commit and a merge, right, those are happening like one at a time. So there's not kind of like things are happening all at once. So what would likely happen? Well, okay, first of all, it's like if you had, let's say on GitHub, your repo, and then I downloaded it, and then Michael, you downloaded yours, right? We cloned each one. We work on our own branches, and then we merge them onto the main branch. What would happen? It would just merge over because we're on our own computer, right? The big thing is like once we started like trying to push them up to, you know, like GitHub at the same time, there might be some differences, and that's where GitHub's like, whoa, like there's some weird changes going on here. You better fix this first. And the question might be like, if we both synced our computers and said, you know, git push now, and we both press enter, like what would happen? It would basically, I don't know what the protocol is, basically whatever gets there first would become the main branch, and then whoever didn't get there first, like the second person, it would fail and say, hey, there's some changes on the main branch that you don't have. You need to pull this and then merge them onto your main branch and fix those. And that's more likely what would happen. Does that make sense? I don't know if that answered your question. Okay.
No, that makes sense. Thank you.
No, good question. One thing I didn't talk about here, and I'm not going to go into full detail because there's a whole bunch of work we can do about merge conflicts. Who's heard of merge conflicts? Yeah, kind of thumbs up, kind of thumbs down, right? Merge conflicts sounds kind of scary. Just know what merge conflicts just means, like that there's a difference in the history that isn't compatible. So it's saying like instead of Git trying to figure it out themselves, like you can saw how this did it automatically. It's like, you know what, this looks complicated. How about you go ahead and figure this out? And basically you have to figure it out and then make that commit, and then that fixes the conflict. But that usually happens when you're working by yourself, is when you do a git push. Let's say you have your local machine, you make some changes, you do a git push onto that, like onto GitHub repo, and then you have another computer, let's say for example, I don't know, your desktop or whatever, and you make your other changes from the old branch, from the old main, and then you push it up to GitHub, and it's like, oh, there's a conflict on there. This can also happen to yourself on just one computer, where you go to GitHub, and let's say you go to GitHub and directly edit like one of these files. I don't know if you guys know you can do that. You can like edit these files directly. So you can edit this stuff or upload stuff. You can change it and then make a commit. You're actually making a commit as if it's another computer. If I made a commit here and then didn't do a git pull on my computer over here, and then make some changes and do a git push, I'll get a merge conflict again or I could get a merge conflict because these things don't match up. So you have to make sure you do a git pull and then possibly fix some stuff and then do a git push. Okay, cool. Make sense to people? Yeah. All right. Hopefully I'm kind of showing you how much different weird stuff that can happen in Git. But yeah, let's keep going. All right. So quickly, I'm just going to show this. I'm not going to show you too much how to like do this because I don't have a specific use case that I can show you guys right now. But one thing is called your remote. So I don't know if you guys know this, but when you guys make a new repo, I don't know if you guys ever noticed when you do like repo.new. Doesn't really matter what it's called. I'll delete this later anyway. So you can see like this set of commands, right? You can just like copy and paste like this. The one part you probably never really thought about is this guy right here. Git remote add origin and this long thing right here. And what this is basically saying on your local computer saying, hey, when I do a git push, where am I pushing this to exactly? And that's what's going on right here. So what's kind of nice is that you can actually see all your remotes. So the way you can simply see your remote is just doing git remote -v. Oops. See this one go, oops. Yeah. What? Okay, you didn't like that. Oh, do I not? Oh, I don't have any remotes on there. Okay, that's because I never connected anything. Let's do remote -v here. There we go. You can see the name of the remote and then the URL to that remote, and then this fetch and push. Basically, it's just so when you do a git pull or a git push, it might have two different places. You might pull from one place and then push somewhere else. But in general, you probably are going to push and pull in the same place. This is just listing like where this comes from. So I can actually add a new remote on here or change this remote and stuff like this. But when you first initially make a repo like this, you can see like there's no remotes here. And that's why Git actually, or GitHub says, where is it? Say, hey, add this remote like this. So I can go ahead and paste this on here, and that would add my remote on here. And then I can push directly from that spot. Make sense? Okay. What is really nice too is that I can actually have multiple remotes. I don't need to have one remote by itself. So for example, a really simple way I can show you this is I'm going to add, now origin is usually like the default what we talk about. I'm just going to call it like other origin. I can add now a new remote. And now if I do git remote -v, you can see here I have other origins. So if I do a git push now, and note that I do this -u because it's setting up the upstream, basically saying, oh, this is the first time you're doing it, just so we know where it's getting pushed to the first time. Other origin, and then I'm going to do, I'm just going to push my main branch, right? So what this is going to do is it's actually going to push it to this remote here, which is this guy. Remember, this is blank, right? There's nothing in here. And I can go ahead and push this guy. Should be good. And once it's done, we'll actually see my main branch here. You can see this. So that's kind of like what we can do. We can also do things like we can push our specific branch in here. So I did main, but I could have done like edits, for example. And if I do edits here, you'll actually see this case, once this is done, a new branch show up here. So if I refresh this page, you'll see 2 branches, and you can see edits are on here too. So you can do this, for example, that way you can kind of like manage multiple repos, for example, or if you make a repo for the first time on your computer, how you can add it on, which is nice. But you can also do things like, let's see, like GitLab. GitLab's another service like GitHub. You can put it on there. You can use the same repo, but just push it to different places. And like I said, just git add remote name, this because I did other origin, and then wherever you're pointing it to. There's other platforms like Heroku. Has anyone heard of Heroku before? Okay, cool. I see some see some hands, see some head shakes, right? Heroku is another cloud service. It's really useful for making like quick, like dirty, like websites. Just like, all right, I just need to make something really quickly, just to show off some stuff, usually like dashboards and stuff like this. Heroku is really nice because it's free. You can actually integrate Heroku in Git, and so all you can do is like you can actually push your work onto the Heroku remote. In this case, they'll give you a special, remote repo, and you can push into that. And it's like that way you can say, okay, like this is going to be my dashboard, and just push it on there, and then keep all your record on GitHub. So that's a really nice thing you can do. There's a whole bunch of other places you can push to, but that's mostly like I think what you guys would probably look into. I put a little link in there to kind of look about that if you're curious. We can rename stuff, simply git remote rename, okay, old remote name and stuff like that. Note that normally we use origin as kind of like the default, like of where we're going to push to, but you can name it to whatever you want. It doesn't have to be origin. And then of course, if you don't want that anymore, you can get remote and remove, right? And you can remove that remote because you don't want to push it to that part anymore. Cool. All right. Any questions on that? That's pretty straightforward, I think. All right. Let's see here. Someone says, I missed a part. The git push -u. What does the hyphen do again? Or -u do again? Yeah, that -u stands for git push set upstream. And basically that's saying like, oh, our upstream is like, how are we going to push it up to? So basically make sure we set it up first before we just start pushing it. So if I do a git push origin main, it's like, I don't know where exactly you should point to do. You should probably set me up first. That's what this -u or -- set upstream is. And then it means, oh yeah, someone answered the question. Good. So perfect. All right, moving on there. So this is where I'm going to talk a little bit about some stuff that maybe you've used it for. Real quick, who signs their commits? Good, you guys don't know anything about it. That's perfect. That means it's actually useful to you guys. Hopefully it's useful to you guys. So signing your commits basically allows you so no one can impersonate you. And so if you guys don't know this already, is that when you make a commit on GitHub, like if you guys ever looked at like your Git contributions, right, your graph right here, like I don't think anyone like really thinks about it. It's like, but like, how do they know those are your contributions? Like, how do they know that you made those commits, right? Well, the way that works basically is they use your username, and they actually use your username email. So your user email when you set that up initially. So one of the problems is that if you actually change your username, you'll see like, oh, I went to 2014. What has Victor been doing his whole life? What what's all this? He's been slacking off this whole year and everything like that. Well, that's because I changed my username, and basically it doesn't know those are my commits and stuff like that. But on top of that, that means someone else can accidentally have a different, well, either accidentally or purposely, can put their own username when they do a git config user.name and then put whatever they want. If they change their email or user into what you use for your GitHub profile, they can essentially impersonate you. And now it's like, oh, now it looks like you're making these commits. And it's not like, it's not even something that's like very hard to do. Like I can, like, for example, this happens to me all the time where if I'm setting something up and I put like example at, you know, example.com, someone else has used that as their Git user profile, and it'll look as if like when I make a commit, as if it's, it'll look like as if I did something like, or like someone else did it. I'm trying to think, I could probably try doing this right now, but basically what it means, like, okay, like you don't really know who it is because it's only based on like what Git is saying who it is. Does that make sense? Like I'm basically saying like, oh, like I write on my, like, it's like your return address, right? When you write on a letter, you guys know what letters are still, right? Yeah, okay. So when you write on a return address, right, and you put like a return address, like no one's confirming like that's the actual like return address. It's just like, oh, if it happens, like, you know, yeah, sure, okay, that's who we send it back to. That's kind of what's going on here. So when we sign our commits, what that means is that essentially we're saying, oh, we are who we say we are, right? We have proof that we are in fact this person. So I'm not going to go through the whole authentication process. It's just like a lot of just like extra like terminal stuff. There's a good, like, you know, GitHub actually talks about how to do this on there. And I thought about showing you guys, but then I realized I had to like kind of show you guys everything that I have signed. And I'm like, oh, I'm also recording this. That seems like a huge pain. So I'm not going to show you guys directly. But just know is that if you do this part, basically can confirm that it is actually you. And what that looks like now is that if you look, for example, let me just go ahead and pull up. Here, you can see a little bit when I do commits. You'll see verified. So you can see this right here. That means it's been signed. That means like, oh, I've actually signed this commit saying that it is in fact, you know, in this case, Mr. Geislinger, this user, actually did this commit and can be verified through GitHub. So that's kind of like what's going on here. Now, once you have this set up, all you got to do to sign your commits, and if anyone's ever noticed me do this sometimes, especially for my cohorts, I'll do git commit dash capital S and then like then do like my like dash M and stuff like this. This dash S basically signs that commit. If I don't sign it, it just it still shows up on GitHub. It still shows up in my contributions, but you won't have this verified part. And that means for you guys, if you're looking at some other work and you want to make sure, especially it's sensitive work, you want to make sure that someone actually like working with a team that's actually someone else made it. You want to check for this verified. Not everyone does it, but if you do this, it means that you can kind of like verify like, yes, like I've been doing inside of my commit. So if you see something that's not verification, it looks fishy, it might not be me. So that's kind of like the way you can kind of prove your work, right? Again, a useful thing to have. It's not necessary, but I think it's like security is always a good thing, especially when you guys talk about data, because we have lots of interesting stuff sometimes where you might not want to be like associated with that, or, you know, someone else get in trouble or yourself get in trouble by thinking someone else is who they say they are. Okay, so anyway.
I have a question.
Yeah.
How common is that in the industry, or is it just like more common in certain fields than others, or like with
signing commits?
Yeah.
Yeah, I mean, it's sad. I wish it was more common. It's not. And for example, like I've done a lot of work with the credit union and stuff and financial institutions, and if anyone's comes from financial institutions, it is amazing how much is not secured in like modern day security stuff. And no one signs their commits on that, which is unfortunate, but also they just try to avoid the cloud in general. But I think, for example, if you're trying to go over, like I mentioned about going to a different repo, so if I just go to Git, oops, not this repo, like all of GitHub. If I go to this repo, I want to check like you can 60,000 commits and stuff like this. And I want to make sure that this person actually has done things. Like I probably want to have it verified, but you can see here, no one's verifying their commits and stuff like this. So it's unfortunate, but I always try to be a little extra secure, especially when working with data stuff. So I don't know, if you don't do it, no one's gonna look. No one's really gonna like say like, oh, you haven't been signing your commits. Like, shake my finger at you. But I think it's something that you guys honestly should practice doing, because I think it shows, if you're signing commits, it shows like, oh, you care about security too. But yeah, I don't know, do a little extra stuff, right?
Well, thank you.
No problem. Yeah, I like to show you guys like be better, right? Like, be the best you can be. This is kind of cut off here. Let me just move this a little bit. There we go. Okay. All right. So tags. Look at that. We still have like 20 minutes left. All right. Better than I thought it might be. All right. So we get tags. So this is where, like, has anyone used tags before? No. Okay. This is where, like, I think most people don't. And honestly, I use this a lot, and it's like much more of a software engineering stuff. But what these tags are basically are a way to say, all right, this specific commit, just like I had like these guys commits. If you remember, I was kind of like hopping around different places. You can say these specific commits are special or like signify a certain change. So usually you'll see this in a lot of software saying, oh, this is a new version of this, you know, like repo, or this new version of this, you know, whatever you're doing. So people will do the things like that. And it makes it a little bit easier, just like I have, like, if you remember, if I do, let's do, I have these different branches. These branch points are going to move as I like progress. The Git tags are kind of like these little like branches. They're not really branches, but they're basically ways for me to signal, like, oh, this commit right here is a special version. So that's kind of what they're used for a lot of. You'll see a lot more software development. I don't see too many data scientists use this, but I'm going to show you why this is really useful when we talk about GitHub releases, which is might be useful for you when you actually try to use large files. So
an example in data science might be, this commit is where I have my model or my pipeline done.
Exactly, right? You're like, oh, this is my version, essentially, like my version to say, oh, I've done this cleaning. Like, for example, like, oh, cleaning is done at this point. And let's say later on you add new data, you can add a tag saying, oh, new data added, or, you know, this data was added, or whatever it is, right? Or if there's a new model. So you can signal like what has changed. And I think that makes it really useful for data science stuff. And that's kind of like how I've ended up using it. But yeah, thank you for pointing out that example, because I think that's a really good one. All right, so just kind of some quick resources, right? I'm not going to go through this. Git has some stuff talking about how to do tags, talking about version. You'll see me usually use version, like version 0. Whatever. You can name the tag whatever you want, but people tend to do this. Usually to talk about, like, you know, your version, you know, 1.13, like what does that mean? Usually that means that your major version is like, oh, this is like my version that breaks things and stuff like this. So version 1 to version 2. Version 2 will actually break things at version 1. So it's kind of like a completely like reformatting. Minor is like kind of like those little mini steps. So for example, we have Python 3.8. We're going to 3.9 soon, right? At least available. But Python 2, which is actually officially dead, is completely different from Python 3. It actually is broken if you try to use Python 2 with Python 3. And then a patch is usually something like, oh, it's something really minor, like we're changing something, like, oh, like there was some refactoring or misspelling or whatever it is, right? So there's a little resource that talks about like how that forms stuff, if you're curious about how to name your tags and your versioning. Okay, so, and I'm gonna try to go through this really quickly, so because a lot of it's like basic tags, like, oh, yeah, just commands and stuff like this. So there's two types of tags: is annotated and lightweight. I like to use annotated because it means that I can say what specifically that tag does. So I can do git tag and then -a and then what I want to call it. So for example, I do git tag -a, and just to show you guys, I can name whatever. I say like new tag, and this ends up looking like a commit message. It basically is just a little thing that says like, oh, hey, like I have a new change in here. So I'm going to say like new change. That's not a great tag message, but whatever, it works, right? And now if I do git lg, you can see here, I have this tag called new tag, right? And I can actually check that out. If I do git log, you actually see like this whole, you can look more into the information about this tag, but I'm not going to go into that. So that's the -a, then your version. You can also just do the message like this, just like you do a git commit -m, right? So you can put the message directly versus like having it open up. If you don't want a message, you could just do git tag and then the name of what you have. And note that this right here is going to tag the specific, commit that you're currently on, right? So if you check out a new one and then commit, or do a git tag, it's going to tag wherever your head is. Okay, so just know that's going to happen here. You can also sign tags, and it's a little different. You just do a -s instead of a capital S. But once you do the whole authentication process, it's a little work. It takes you like 30 minutes. You can sign your tags too, and then people can verify that those were tags that you created. It can also make, for example, like I can make let's say other tag. I can make multiple tags on the same commit. So you can have multiple ones, just like you have multiple branches. So, and what's nice is I can do, like, for example, git checkout live demo. I can do git checkout and then let's call it new tag. Oh, I get to do switch, but well, I'm not in the branch, but you can see I'm on the actual, like, I'm actually on this commit right here. Okay, cool. All right, let me just go back to git checkout main. Okay, all right. So we can also take a previous commit, right, and actually say, oh, that's a tag. So for example, if I have, let's say, git lg, and I want to commit this one right here, like, oh, this commit 3 was like super special. Let's say this commit 4, this big file, I can git commit, or sorry, git tag, and I'm going to call it, I don't know, version 1, 0.1. Why not? And I can say this specific hash right there. And that will actually put the tag on that commit right there. So that's useful. Like, for example, let's say you've done all your work and you're like, oh, I want to kind of tag this part in there. You can actually add those tags later on. Okay. The thing about this, though, I don't think I have a remote on here, do I? No, I don't have a remote. Sorry, I want to add a remote really quickly. And I'm going to force it. Oops, I gotta. Not gonna do that. Okay, that's fine. I was gonna try to show you guys really quickly, but that's okay. I think you guys will get the point. I can push my tags by git push -- tags. If git push does not automatically push your tags up, so you have to actually manually push your tags individually. And then you can actually push a specific tag too, if you just want that one tag at a time. Okay. Deleting a tag, it's pretty easy. -d and then whatever the name is. And then to delete it's a little bit more work. The easiest way to do it is just git push origin -- delete, whatever the name of the tag is. That way you can get rid of it. You'll sometimes people reference it like this. This works too. This looks a little more cumbersome and it's hard to remember. I always forget if it's ref or refs. So this is usually the easiest way to just delete it off the remote. Okay, cool. So I kind of showed you what tags are. I kind of showed you a lot of stuff, like I'll show you a lot of stuff like for GitHub, hopefully. And so I want to show you guys like why is this useful. So I've got about 15 minutes. I'm gonna kind of skip around a little bit, which is good. So I'm gonna go to this last notebook, large files, which I think is the most like relevant for us using Git in GitHub for data science stuff. So, all right. So large files can be really like no fun, right? Like as you guys probably have experienced at this point, like uploading large files and stuff like this. First reason why is GitHub like gets upset, right? If you have a file that's too big, GitHub's like, whoa, that file's too big. Like, what are you doing? You can technically go like, there's actually, it's no longer in the docs anymore. It turns out like they've recently removed it. It used to be that there's a hard cap at 100 gigabytes. If your repo is 100 gigabytes large, they'll say, oh no, you can't do that anymore. But more likely what's going to be the issue is that individual files are limited to 100 megabytes. And this is where I've had people say like, oh, I went ahead and paid for it and I did these things. I'm like, don't pay for it. Don't spend your money on that just to upload data, because there's better places for you to do this. So the first thing is that GitHub doesn't like big files. Second reason is that you shouldn't like big files either, is that when you have your repo and you add this commit and changing the files and stuff like this, one of the problem is that your big files are going to be basically kind of like stirred in and compressed and hashed into your repo. So basically once you add your big file in there, let's say you get rid of it later on, your big file, because it's part of the history, is going to stay within that history, right? And so that means anytime you do a git push or git clone or any of those things, you're going to have to download that whole history with it, which can be really, takes a long time, it's uncompressed. I've done this early days and stuff like this where I had like a huge, file or set of files like 2 gigabytes large, and like every time I cloned it, it took like 30 minutes for it to like download and go through all that stuff, and it's a real big pain. The other problem too is like if you make a change on that data, you should probably say like, oh, this is a new change on my data now, right? Well, the problem is now it's going to try to keep record. If your data is already compressed in some form or fashion, it's just going to try to save the whole thing all over again, which again is super annoying too, because now you have a larger file on here. Like you have 2 separate larger files and it has to download all this stuff. So we want to try to avoid this kind of situation. So there's a couple solutions. So first solution is just don't get in this situation to begin with, right? Like don't have large data. So a really easy way to do this, do you guys know what .gitignore? Thumbs up if you've heard .gitignore. So .gitignore, if you guys haven't heard it, it's basically just a special file that we can just make, right? So if I do, for example, .gitignore on here, I can add whatever I want in this. And for example, I can add, ignore my data folder, my models folder. So I'll keep all my models in there, right? And what's nice there, if I do git status, you can see my got ignored here. So I make a, let's say make a directory, oops, called data. And let's just touch data file. And you can see here is that because I have this .gitignore in here, the data file does not show up. If I get rid of, let's say, I'm just going to move .gitignore so it's not that name anymore. I'll call it like gitignore. And I do git status. You can see, hey, there's all my data stuff. So that .gitignore basically said, hey, ignore any files that are named like this. And that kind of helps prevent you from accidentally adding that thing. So one of the first steps you should do for like pretty much any repo is after you initialize, like I wouldn't even say add a readme first, it's add a .gitignore. And in fact, if you look at GitHub, if you go repo.new, you can actually add a .gitignore automatically. And you can even choose using Python, which will make you ignore all that like .ipnb checkpoints and stuff like this, which is really useful. Make sure you add then to that thing your data or your models folder. That way you can make sure it automatically ignores and you don't actually add it onto your repo. Okay, makes sense to everyone? Cool, all right. So that's like the step like 0. It's like just make sure you don't add it by accident. But like what do you do about this data, right? Because now you're not adding in there. So one thing I tell people is like at the very least document, and you guys should do this no matter what method you do, document where your data come from and how you get it and how they can get it too. And that way someone can reproduce your results. So many times people will make projects, and not just like Flatiron students, just people in general, like data scientists. They'll make a project, they'll do this stuff, but they don't talk about where the data came from. And it's like, well, that's cool, but like, how do I know? Like, it starts first with data science, right? Like, we need to figure out where this data comes from. So make sure you at least put it in your notebook somewhere that says, hey, this is where this data is coming from. And that way people can reproduce it. Kind of the same idea is like for environments like Docker. We won't go into Docker, but the same idea there. It's like you kind of want it so people can reproduce your same results. Okay, cool. Now, the first part is like, what if you accidentally already added this in here? This is where you can remove it. I'm actually not, just because a little low on time. We'll see what we can do. But we're going to skip over this part a little bit. But there's actually a really great article from Aaron Hoffman. I don't know if anyone knows Aaron Hoffman, one of the other instructors for the data science program. I can't remember what cohort she is. I'm online, so I never remember who where everyone is, because everyone's like just like, oh, just not online, but not everyone's online. Write a great article like what happens if you have this this issue where you add data onto your profile or onto your repo, and then you need to remove it. And so they actually talk a little bit like how to do this in rebase and stuff. If we have time, maybe I'll show you guys a little bit like what that looks like. But this article is like really great, in depth. Definitely check it out. All right, cool. So I'm gonna skip over that. LFS, get large file storage is kind of like the right way to do it, or that's where everyone tells you, oh, use Git LFS. I don't like LFS. It just kind of moves the problem slightly off to the side, and it's all right. Basically what's happening is it's creating a pointer file on your Git repo, and you save that pointer file that says, hey, this is where the real data or big file is stored at. And then it saves it to another place that's not GitHub, which is like fine. But then the problem is now is like, you have to rely that this place also stores in the right place, and it's not really there. And it's kind of like a little confusing at the same time. And it's kind of messy, to be honest. You can check it out and stuff like that and use it. But generally, I think that usually when people use this, they kind of go like, kind of do a little squirm like, it's not really pretty. Like, it's just kind of a hack. And that's what this is. Basically, people realize like, oh shoot, our files are getting really big because people's systems are getting bigger and bigger. And so there's actually created with like GitHub, Atlassian, a few other organizations. They said, all right, we're gonna make this new open source tool called Git LFS to kind of alleviate this problem. But it's meant more for software engineers than data science stuff.
Also, there's a cap on the amount that you can put in LFS in general as well before you have to start paying for it. So
Exactly, because someone else has to store it, right? So it's like you have to put it somewhere. And that's where I will tell you is that any solution I should tell you, at some point, someone's going to say, well, that's a lot of data. Like, that's going to be too much. There's some ways you can get around it and stuff like this. But I think LFS is just making you think that you solved the problem. And in reality, it's like, oh, no, it's just like move to somewhere else. So I don't like using LFS in that way. So my little mini solution, which I had honestly recently had found out, called GitHub Releases. Has anyone heard of GitHub Releases or from software engineering? Okay, so this is technically, and I will technically go a little bit over if I have to, because I think it's useful. GitHub Releases is meant more for like software engineering kind of projects, where it allows you basically to, like if you're on a Git project and you're doing a software project, and you make your stuff and you're like, oh, cool, I got version 1.0. Cool. Now I want people to use it and stuff like this. You're probably not wanting to people say, oh, go ahead and go to GitHub, download this part, download, like clone the repo, and then build it yourself, basically with like, the different commands and stuff. And then you have your program. So there's something called a binary. And a binary basically is kind of like someone's already pre-compiled it for you. So you don't have to do all that work. And they say, oh, download this. And that's essentially like when you download an app or a program or something like that, like in Mac, like when I use these guys right here, I don't have to think about like doing anything special. Basically, I just download that specific file and I'm ready to go. That's essentially what this is built around. And so the idea of releases is it's kind of tied to the idea of Git tags. So when you have a different tag, which is usually versions and stuff like that, you can actually add different files to it, which would be kind of like different like binaries and stuff like this. So what's kind of nice about this is also creates this unique URL. So there's a couple things. Like one is that we actually can separate out our like files into a separate thing that's related to the tag. We can also have a URL, which I'll say like why that's really cool in a second. And it kind of keeps it a little separate. Now there is still a size limit. The size limit basically is 2 GB per file. Which again, like, for some data sets, that's just too small. But there are ways, like, for example, you can split up your data into like different parts and then at least have like 2 GB size files. I usually like to zip my files together. And that way I have like one thing, I just download that one specific thing. That's a good way to kind of compress it all together. But even if that's like too big, like, or you have like 4 GB or 10 GB or something like that, you might want to split into smaller files. And then that way you have separate zip files. So, but once you have that, you can actually attach it to your specific release. And you can then reference that release, and it's a little bit easier to manage and stuff like that. Okay, does that make sense to people? Kind of like the motivation. Okay, so I'm going to show you guys a little bit what this looks like. So let's see here. So why does this matter? So what's nice is that we can do things like adding our data files. Like if we have, some, for example, our first initial commit where we have this new data, we can actually put the data directly on there, assuming it's like small enough. Oh, I mentioned there's a 2 GB limit. The good news is that it doesn't seem like there's any limit to like how many files you can put in there. So like, like you probably don't want to put like 100 GB because that would be like 50 different files, but you could technically do something like that. So it's relatively manageable. But we can actually attach, things like data files. We can also attach, like when we train our model sometimes can be very, very large. Sometimes, more than 100 megabytes, right? So we can actually attach our model or zip, our checkpoints and attach that in as a release. And what's nice about that I like is that it encourages you now to work as if like when you make a file or when you train a model, that is a new version of your, your project. And you can attach now like the model artifacts. We call those artifacts like the weights and stuff like this and like how the model is structured. So think like that model.h5. You can attach that directly onto your tag, your release, and that way someone else can find it too. And you can kind of reproduce those results. So it makes it a little bit easier. Some disadvantages for this though is that it's kind of like you have to be in charge of it. So you have to like make sure you're uploading the right file. There's not like a show like differencing. Like, it's like if I had a like data.zip on one file and then have a new data.zip for another like release, like it's not going to show what the difference between is. You have to rely on the fact that you are going to document that and like it's clear for other people to find. But at least you're able to do these kind of things and it's free. You don't have to do anything special for like relatively small projects. So anything you guys do at Flatiron probably is perfectly fine. And it allows you to do a download link, which I really like because it means that I can send this notebook to anyone I want and say, all right, if I include that download link in there, I can say, just run the notebook. Don't worry about it. And just let them go. And what's nice is that anyone can also be a cloud service. So if you use Kaggle, you guys know what Kaggle is, right? Okay. Kaggle has Kaggle kernels, right, where you can like run notebooks. I can just send my notebook up to Kaggle and just have it run. And I don't have to worry about it. I don't have to worry about uploading data. I don't have to worry about making a new Kaggle data set or whatever. I can just say, all right, here's the link, just download it to the program, right? And just run from there, which is super useful. Okay, so that's kind of like where I'm at with GitHub releases. I will say is that there's some other solutions. I know Alvaro a while back talked about DVC, I can remember, data version control, right? Yeah. It's actually, it's a pretty cool one. I haven't played around too much with it, but I do know people are playing around with this. The advanced version of what this release is basically using like an S3 bucket and saving like your files and stuff like that into there and then referencing it. But I'll tell you is that most people don't even like try to do that. So like doing this for your little projects and stuff like that, I think it's like the perfect amount of like how much work you have to put into it without having to like learn something completely new. And it shows that you kind of like think about these things, which again, for employers and stuff like looking for, says, hey, you're thinking about this. And you can also talk about it in an interview saying, hey, this is how I made sure my product's accessible and also how I can like look at the artifacts and stuff like this. Cool, I saw a couple, yeah, fills in some gaps. Yeah, that's good. So that's my hope. So I know I'm kind of at time, so I'm gonna spend a little bit more time to go over releases and stuff like that. Everyone good with that? Okay, cool. So I'm just gonna show you a project that I have made in the past, which makes my life a little bit easier so I don't have to look it up. Oops. So, okay, I'm just going over to this project that I've been messing around with for a while now. And so remember how you can make tags and stuff like this, I can push those tags. We can check this out with releases. So you can see here in my tags, I can see the different ones I've made. For example, here's my version 11 or 0.11, right? All data with aggressive dropping of straight values. So I can kind of add these different parts in here and I can make a new release. So once I have these tags, I can actually attach a release to it. In this case, for example, I actually have like, you know, my different model of how I trained it. You can actually see a little bit of information about what I've done. I also put in like this case, like this is a recording of, it's basically, just to give you some background on this project, is I am using, I have a simulation running that basically tries to train how to make this self-driving car go. And so this like recording basically shows how this model performs. You can see how well it performs and stuff like this. So I can quickly like show those results on these different versions and stuff. In this case right here, if I'm seeing this right, where is it? So I can actually show you where I have new results. So this, for example, is all me kind of putting things like what I've changed. And I can also see when I have new data, for example, you can see data.zip. I can actually take this guy and you can see this copy link address. I actually have an address now for this data.zip, which allows me now to download this directly. So either I download it for myself, or I can put it in my notebook even and say, hey, download this data, and I can refer to this specific URL. So that's what makes this kind of like really convenient. Just to show you guys a little bit about when I do this model, like what it means, like what I mean by having in my file. I have this little quick set of like files right here. So basically this right here, if you guys seen OS, right? OS basically lets me navigate through my system. There's a couple things like URL lib, you guys probably know this one, to download files, and then zip file, which some of you might not do notice. This allows me to unzip the file and like load it directly into my directory. So what's nice is that basically I check, say, hey, does this path already exist? If it doesn't exist, go ahead and download the file itself, right? So the zip file. And then without having to like save the data.zip and then uncompress it and then like get rid of the data.zip thing, this basically will say, all right, here's data.zip. As it comes in, go ahead and like open it up, extract it out, and save it into this path. And so that's what this function does completely, along with these libraries, right? And so that means I can actually have this release right here, is because I'm using the data from 0.14.0, right? Data.zip, and that downloads it automatically. And what's nice about this is that I can go ahead and give you guys this like URL, this notebook. I can send it to you, and I say, just run the notebook, right? And as long as you can run the notebook, this will download it automatically and just run everything all the way through. Also really useful, since I also like to push this up to Kaggle. I can have Kaggle run this in the kernel and just have it run and not have to worry about like, oh, let me upload this new set of data. I can just say, all right, let me just change this URL and Kaggle will figure it out. So that's what makes this really convenient, I think. So anyway, that's kind of like what this release looks like. Any questions about this so far? Hopefully you guys see like the use case for it. So I'll show you guys really quickly. I can, for example, draft a new release and I can tag it to a specific, part. In this case, I can only, since I don't have a tag specifically, I can take my tag. Let me just make a new release right here. Oh, I already started a release right here, but I could then put whatever I want in here. I can upload specific files and stuff like that, and then actually write about like what this is, document it, just like I would do like with a README essentially. And that way this allows me to kind of go back a little bit. And again, like this is where like, this might be for like a small project. I probably want to think about this beyond like if I was doing this for a full industry, but if you're doing like something like contract work, or if you're just trying to show a cool project that you're doing, I think this makes it really easy to do it without having to like, worry about AWS S3 buckets, downloading this, uploading it there. You're just like, okay, I have it in here. I got my model.h5, load into here, describe that is, all good to go. And what's really nice, again, like I said, is that like if you have your model, for example, or your data, you can actually take this model.h5, right? And you can transfer this over to somewhere else to another project. So you don't have to like retrain this model or say, oh, what model was it? Like, which of these model, like, model _1, model _5, like which one is this described? I can just say model.h5 and just know it's going to be a specific one based on this release format. Cool. All right. Cool. So yeah, any questions on that? Alvaro, I think I see your hand.
Yeah. So when you create a release, you're basically creating a package, right? This is all compressed into one file.
No, you can download individual. So for example, I have this model H5. I can download just this model H5 or just this output or actually the whole source code itself. So you can just say share just that specific one, and it's just associated with that specific commit in tag.
So for the purpose of managing large files, this only really gives us the ability to just zip it up and keep it in one place. And that's really it, right?
That's right. It's not going to keep track of like any changes. For example, like what is different between this model H5 or let's say this data.zip to something down here with data.zip. It's not going to know the difference. It's just going to, oh, there's just a different file like that you have in here. So again, this is like disadvantage for something like this is that it's not going to keep track of all the different changes. It's just a good place to organize yourself. Like if you can organize it well, awesome. At least you can document all these parts in here, but it's all reliant on you. So that's like the biggest disadvantage, I'd say. This is where like, I know you had mentioned DVC. I know in other version control systems that are focused on data science, they're, from my understanding is that they're not super matured yet, where basically if you ask a data scientist in industry right now and you ask them, what do you use to save your model artifacts? Everyone goes, whatever we can get our hands on, essentially. Like, and some people go, what do you mean model artifacts, where they're not saving anything, which is also super bad. So this is where like I will straight up say is like, this is not going to be the best solution overall. And I think that there's much better solutions, like other things that will better track your data and stuff like this. But I think this is a good enough solution for a lot of the projects people are doing. And then what I will say is that as you guys get your first job as a data scientist or machine learning engineer, whatever you end up doing, is try to bring this idea to wherever you're working, or if they already have this process, you won't be too unfamiliar with the idea of saving your results, saving your different artifacts, saving your data and stuff like this, and at least having an idea of like how to version it. That'd be kind of like what my goal is for you guys for this. Yeah, I don't know if that kind of like addresses a little bit like what you're thinking, Alvaro.
Yeah, I mean, for me, what I'm trying to understand is really how that addresses the storage of a very large file, right? Because to me, what I'm seeing is that my file is still being stored in GitHub, and it's aside from the fact that it's zipped up. How is that really solving my problem with a large file?
Yeah, I would say it doesn't solve the direct issue with like, if you have a 10 gigabyte large file, which is basically, let's pretend the 10 gigabytes is because you have many, many images, right? This does not solve that problem, right? Like it's not going to solve it in the sense of like where you can start, because you can't just zip it and then upload it in one place. It's not going to solve the issue of like, what if you change that file, like those files now and make new stuff in there. But it helps you at least with managing those files. So for example, if you really wanted to use like 10 gigabytes and stuff like this, in the end, you're gonna have to store it somewhere. And the best solution at that point is probably just getting an S3 bucket and basically uploading on that spot. The only issue with having very large files like that is that means that you just have to download it whenever it comes through. If you can think in ways of like making a smaller data sets and put them in like subsections of this, at least then you can download those parts of your data set and use that. And then if you have, for example, let's say data 0, data 1, data 2, or whatever, like maybe there's random subsamples, right, of that data set, you can then maybe design inside your notebook itself, combining those data sets together because they're formatted in such a way that you can combine them quickly. But it's a different kind of problem for sure.
Yeah, because I mean, for me, what I'm doing is basically what you just did, downloading the zip file, but I'm just loading it from it. I'm downloading it from its original source.
Yeah, the only problem with the original source is why I mentioned this.
It could change.
Yeah,
things change, and that's out of your control at that point.
Yeah, but yeah, you're right. Like if you had it just from a single source, like if you're like, oh, here's the zip file, you could just keep downloading. Like you could put the URL from there. At least this way, if you did want to add new stuff, for example, you have a little more control over it and like be able to document a little bit what's going on. But it's by far it's not a perfect solution. Yeah, thanks for adding that in though. All right, cool. Any other questions or concerns or comments about this process or anything we got through? Yeah,
I have a question. So because the lessons always had the data up on GitHub, it's just something that I had always done with my projects. But like, I know you talked about it creating bloated repos, but like, what is so wrong with that?
Yeah, the main thing is that I will share, for example, let's see here. Oh, I have to go to my profile. So I have a project here, and this is early days Victors with like data stuff, like when I was messing around with some things. I was doing this finger spelling thing, and I have my data on here. The problem is that you now have this data, and if you try to clone this guy here, it's going to take a long time before you can even get into your notebook and stuff like that. Like, for example, if you just wanted to check this out and not worry about the data, like it's like, I'll download the data later on. You're forced to essentially to download that data and uncompress it. And so one thing I'll say, it downloads it in a compressed format and then tries to uncompress it with git clone. And that takes time as well, which can also overwhelm your computer, especially if you have a very, very large data set. Now what happens is that it's going to take a long time for it to uncompress and you can't do anything else. So that's where like Git LFS really does like at least streamline it, where you can clone your repo right away, look at it, and then get the file, like the data files later on. Like let's say like, let's just pretend like, oh, you can do it overnight, but you can also do it as like, oh, while it's downloading, you can do something else. Where this one is like, you're kind of stuck until it completes actually going through and everything like that. I'd show you guys this now, but I kind of worry about my bandwidth kind of like, like taking off Zoom and stuff like this. But if you're curious, try cloning this and you'll see a little bit like what I'm talking about. Is that like, it's like, oh, and that's only because like there's been 2 changes in the data set itself. So yeah.
That makes sense. Thank you.
Yeah, no problem. Yeah, good questions. All right. Any other last questions about this kind of overall process? I know people probably wrote a couple things here: mirroring, detaching, retaching head. Yeah, this is where like, you know, we could talk about Git in general and stuff like this, but hopefully, especially with detaching and retaching head, you can kind of think a little bit of like when you do Git checkouts and stuff like that, you can kind of manage a little bit of like where you sit on this like timeline of commit history. Mirroring.
Yeah, that part, like that part of your presentation actually helped me with what I'm trying to mirror and clone, and it's a big mess. Basically, I did individual repos for all of my Flatiron stuff. And now I have, like, my GitHub says I have 400 repos, but I only have like 8 projects in there. So I want to kind of adjust that. And so I'm trying to figure out how to do that. And I think that having the multiple origin points or multiple remote pushes will help me a lot. Then I can delete those independent repos.
Good. That's great. Yeah, I think that's the hard part. I think this is something I try to tell students early on a little bit, like my cohort kind of knows a little bit, is that like when you start off, you're like, oh, I'm just going to fork this repo. Like, you know, it's cool. And then you realize like by the end of it, like, oh, I have 500 repos in this thing. You're like, oh man, like it's like, and there's not a problem with that by itself, but it might kind of reduce a little bit of what you're trying to like, you know, show off. So one thing I'll say too is that one thing you might want to do is try to pin like your repos there, right? So that at least you can say, oh, like these are ones I want people to see. Do you guys know about making this special repo that shows a little special README here? Cool. I see a nod from Elizabeth. I see Albert looking a little closer, so maybe not. If you make a repo that's the same name as your username, so if I go to this repo here, you can see like the same as my username. You can actually add a README, and whatever you put in this README will actually create, will actually show up now on your GitHub profile when someone loads it up. This was like a relatively recent change. I think it happened in the past like couple months that someone put this together. But I'd suggest like, yeah, make something like nice, at least somewhere where people can find you. Like, you know, I showed you a couple examples like how this would work and stuff like that. Maybe put a couple of your repos, or not repos, yeah, a couple of your repos in here, your projects that you're kind of like most proud of that you want people to see right away. That way, when someone goes to your GitHub repo, right, like this is the little secret, right, is that like no hiring manager, no recruiters really gonna like dive deep into your any one profile, but they're going to see some initial stuff, and you want them to see the stuff that you care about and you want to have them stand out. So that's one way you can kind of help to, but yeah, unfortunately that repo thing, sometimes you get so many repos. I mean, like at a certain point, it doesn't matter too much because again, are people really digging super deep into your notebook? But like sometimes I have like really old repos. Like I think I have things like way back before, like when I was like in university, and maybe you're not that far yet. But there's some random stuff I have. And so you'll see people, if you're ever curious, look at other people's like repos and stuff like that, or GitHub profiles, even people who do a lot of stuff, you'll see some random stuff in there that people just never delete. So it's not uncommon either. Yeah. Cool. Well, all right, awesome. I know we went definitely over. I tried to make it long enough so we can make sure we can get through stuff, but you know, that's life. But thank you everyone for showing up and everything like that. I'll make sure to have the recording out so you guys can see it. I'll try to link the different resources that kind of mentioned here. But if you do follow that whatever one repo I had in here, here it is. I try to put all the resources in there and everything. But yeah, feel free to reach out and everything like that. Yeah, cool. Well, I guess I'll stop the recording here and we'll stop here. And thank you everyone again.
Thank you, Victor.
Thank you, Victor.
Of course. All right,
Thanks, Victor.
Everyone.
Thank you. Thanks, everyone.
Good.